Hello and welcome. My name is Sarah, those of you who are joining us for the first time in our video series on coding. Today we're going to talk about debugging. But first, my little bit of a quarantine update, or shelter-in-place update. I have been working from home and staying at home for quite a while now to keep myself and my family safe, but we're coming up on a lot of holidays. Passover is going on right now for me and my family, and also there's Easter coming up this weekend. So I'm incredibly grateful that we have a lot of video chat technologies, so I can, even though cannot share the same space and be in the same room for seders and dinners, we can still connect from afar and have these celebrations of family, which this holiday and these holidays mean to a lot of us. So I'm incredibly grateful for that. So that's kind of my update, really exploring that and finding new ways to celebrate these holidays and be with my family, even though we can't share the same space. So our video on debugging today. Steven's been making a video series, and actually just today he's come across a bug in his process. So he spent some time breaking down what that process is like for us, talking about how he creates the videos and the usual process that he makes and the bug that he's come across. There's a lot of amazing stuff in this video. I really encourage you to check it out. The link is in the description. But today we're just going to zoom in on the part when he talks about how he's going to go about debugging this problem. A little bit of context on what the problem is. Steven's created code so he can input a couple different clips to create a 1-minute segment, and he can tell it exactly the amount of time and what he wants it to look like. That code will output an XML file or a file for his editing software Shotcut, and he can take that and then output that into a larger file with all of the 1-minute clips of his 5-minute episode. Pretty amazing stuff, but for some reason 1 minute is just not working. That's why you see that technical difficulties skip this segment in there. So we're going to hear him talk about what his debugging process would be like and talk about some strategies we can use ourselves as we start to code or continue to code or become experts in coding. We're always going to need to debug. So let's go ahead and check this out and see what Steven has to say on this subject.
I wish I could just keep the camera rolling while I debug that, but the thing is, I don't know if that's going to be a good story. I don't know if it'll be interesting, and I suspect it probably won't. I suspect that what will probably happen, and I just say this from past experience, is I'll work on this for a few hours and I'll find out that it's something dumb, like maybe if I just restart my computer, it fixes it. Maybe I'll work on it for several hours and realize it's a subtle bug in my code, so that it was putting out a Shotcut file that can be opened in Shotcut but doesn't render.
All right, quick pause right here. I want to chat about what he's doing right here is a strategy already for debugging. What the strategy is actually walking through the possibilities. As soon as you come across a bug, starting to think, what could this be? And getting as wide a view as possible. He talks about possibilities out of his control. Maybe I'll just restart my computer and it'll work. Always a good thing to try. Talking about, well, maybe I'm making an assumption here that this is doing something it's not. Let me walk through this process. So starting to think of those possibilities is a very important part of the debugging process. Okay, let's see some more of these strategies here.
I'm not sure why, but one of the things I'm going to do to try to get traction on the debugging process is that I'm going to use an idea called binary search. So something in this video doesn't render. I don't know what it is. Maybe it's one of these clips. Maybe one of the clips is corrupted, but I don't know which clip is corrupted. So I'm going to use something called binary search. I'll try rendering the first half of the video. If that works, I'll try rendering the next half of the video. If that doesn't work, that tells me that the problem is in the second half of the video, and then I can keep subdividing the second half to try to isolate where the problem is there.
All right, so binary search, that's the first one we're going to talk about. Oftentimes how we'll do this is actually comment out parts of our code. So it's very good to know how to comment in whatever language that you're using. We're going to talk more about a binary search and binary search algorithms in a little bit. Let's go ahead and continue.
If both halves do render, that tells me something else, that it has something to do with the length of the video. But that would be quite puzzling because I've rendered many longer videos. In fact, I render a 5-minute video every day, and this is just a 1-minute
So
video.
he's more
So that's why
theorizing
my
now.
theory right now is that there's some kind of corrupted clip, something wrong with the data. Well, that's it. That's the idea. That's my plan for the day. Is I'm trying to get this episode out. I'm going to do some debugging. And by the way, what I did just now is so rubber duck debugging. I'm going to give that to you as a homework assignment to anyone interested in going beyond what I talk about in this show. So,
all right, rubber duck debugging. We're actually going to pause the video here. Rubber duck debugging, it's a strategy where you go ahead and you talk through your code. You place it's called rubber duck debugging because you place a rubber duck next to your computer. And every time you come across a problem, you talk to that duck, you tell that duck every single thing your code is doing. You walk through it line by line. And oftentimes just talking it through, you'll discover the bug yourself. The rubber duck isn't super helpful, won't pipe up with some suggestions, but just this tactic of talking through your code helps. I have had personal experience with this. When I ask somebody's help with my code, if I've tried to search it, I can't figure out the problem, finally I ask somebody's help, one of my coworkers, in explaining to them, this is why it's not working, or this is what I'm trying to do. Oftentimes I just solve it myself. I'm like, well, I think it's going, well, no, I just found it. Never mind, thanks. Happens all the time. So it doesn't have to be a rubber duck, but that's why it's called rubber duck debugging. Let's zoom in a little bit more onto the binary search. As Stephen says a little bit later in this video, binary search algorithm is often used as a way for computers to do searches. So let's zoom in on that algorithm first before we start discussing how you can use it when you're debugging your code. So over here, I'm going to go ahead and pull up a list. My favorite way to talk about this is my favorite way of talking about binary search and how it works is if you were to do guess a number. You can actually try this one with your friends and family. It can be a fun trick. So if you ask somebody, think of a number between 1 and 50 and I will guess it. Here I've done a little bit of pre-work here. I've chosen a number, but I'm going to pretend I don't know that the number is 35. I've got a couple options. So does a computer. If I'm looking for this number, I'm guessing this number, I could go in a linear fashion. Is it 1? No. Is it 2? No. Is it 3? No. Is it 4? No. Is it 5? No. Is it 6? That's going to take me a long time. In fact, it's going to take me 35 guesses before I get there. However, so that's a linear search. I could do it randomly, just guessing random numbers, which tends to be the human tactic, what we tend to do, and that could take up to 50 guesses. No telling how exactly many it's going to take. But a binary search would do something like this. So it'd find the minimum and the maximum, and then find the center of that. So the center here is actually, so 25 is just above center. There's 25 here, and there'll be 24 options over here. So I can click 25, and then I ask, is your number higher or the same as 25? So in this case, the number is higher than 25. So I already know I can just knock all of these ones off the list, and we just know they're not going to be, that's not going to be the option. So my next question is going to be to do with this one. So I'll actually bring this to another line. There we go. So now I find the one in the middle here, which is just about, it's actually between 37 and 38. So I might pick 37 and say, is your number higher than 37, lower than 37, or the same as 37? We know here the number is lower than 37. So I know that it's not 37 for one, and it's also not a number that is above 37. So I can cross all of these ones off. I'm going to turn those red so we know, and I'll copy and paste these ones onto another line. So now we're here. I'm going to pick the center of here. So let's see, I've got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my number's center will be just about 31. Perfect. So I can ask, is your number higher than 31, lower than 31, or the same, right? I know it's going to be higher, so I can knock off 31 and everything below that. Now I'm just dealing with these numbers here. Let me pull that down to another level. 34 is the center now. I can ask, is your number higher, lower, right? So we know it is going to be higher than that because I got another answer. And then here, I can just pick one of these two because again, they're split into the center. So I can say 35 is your number higher, lower, the same as 35. And it is 35. So I know it's not. So then I've won. I can cross off this one. Yay! So I've gotten my answer here. So that's a binary search. So as opposed to taking up to 50 times, as opposed to taking 35 times, I was able to figure it out with 1, 2, 3, 4, 5 questions. That's the value of a binary search. You can actually see it's a common coding exercise in a bunch of languages. You can see it on Scratch here. Scratch has one here that's very cool. I'll link it in the description. Someone created this one. Pick a number between 1 and 1 million. All right, so 1 and 1 million. So I can come up with, let me say I pick 57. All right, so it's asking me, is it higher or lower this? It's lower than that. Lower, lower, lower. 57 I'm looking for. So I'm going quite down here. They've asked me 10 questions so far. 11, 12. Okay, it's lower than 62. It's higher than 31. It's higher than 47. It's higher than 55. Lower than 59. They guessed it in 19 questions, right? That's a ridiculously high number, and they were able to figure it out in 19 questions. So if you think about what this would look like in debugging, say you have 1 million lines of code. You could linearly test the first line or the first function that's doing. That doesn't work, try the next one, try the next one, try the next one, try the next one. You could do it randomly testing it. Or you could do a binary search. You could comment out half of the code, run the first half. Does that work? Yes? Then you know it's not, the bug isn't in that first half. You can sort of comment all of that out. Look at that second half. Does that code run? No. Then you know it's in there. Take that code, cut that in half. Is this running? Is that running? No. Take a look at this. Divide that in half until you end up to the exact line where you know the problem is. Is this a perfect solution? No. The reason why is because, one, you could do that whole process and everything works and you don't know why. That's one reason. Another is there could be multiple bugs. But that just means that you run the binary search a couple times. So it's a great way to start. It's not just an algorithm for computers, but for humans too, for debugging. So with that and rubber duck debugging, we hope that you can start seeing bugs as more of a challenge and less of a stressor. And we'll see you in the next episode. And until then, stay safe.